Hey everyone, it's Miss Gubrud. Today's lesson is lesson 1-4. Unit rates is what we're talking about. Of course, we're going to still continue to talk about constant rate. And you see my awesome math skills right there and my awesome drawing skills. We're going to be talking about snails, and that's going to help us think about constant rates. So I've got to tell you this morning, we're going to quickly review some of our vocabulary from yesterday, and then we're going to, oh, holy cow, I've got something weird going on here. And then we're going to talk about today's lesson. So here's our vocabulary for from yesterday, if you remember. Whoops. There we go. We talked about rates, the speed at which something happens. A rate is how fast something happens, and we almost always use the word per when talking about it. Miles per hour, dollars per pound, days per week. Our constant rate means it has to happen at the same time, and we talked about that in real life. How often does that happen? Well, a lot of times it's not constant, but when we're learning about rates, we're going to pretend things happen constantly. So we're going to pretend that we're driving the car at the same speed, or pretend that we're always eating 2 apples a day, or pretend that we always today collect things in the same rate. So there's our rate table. As you remember from yesterday, we're going to just put our data inside that table. That's how we're going to keep ourselves organized. Now, today, here's something new for today. Today, we're talking about unit and unit rates. And if you think back to what you've learned in other grades, unit means one of something. So if you're talking about a unit fraction, it's 1 out of 3 pieces. 1/3 is a unit fraction, 1 out of 3 pieces. If you're talking about 1/8, it's 1 out of 8 pieces. Now, here's an example. Maybe you've watched some shows on TV that are kind of like police shows. And a police dispatcher on a show, you hear them call over the radio and say, Unit 72, please respond to the complaint of a barking dog. Who responds in that case? It's 1 unit. It's 1 police car. That unit 72 that they called, that's the one who responds. But sometimes on the show, you might hear, all units, please respond to a bank robbery in progress. Who goes then? Well, it's everybody. It's all units. So that means everybody goes because unit means 1. But if it calls for all of the ones, then that's everybody. That takes us to today's new vocabulary word, which is unit rate. So it's again a rate, the speed that something happens, or the amount of something for every one of something else. That's where the unit part comes from. So we use the word per, or each, or every. And when you hear those words, per, each, and every, you're thinking 1 per 1. You ride your bike 8 miles per hour. That means you travel 8 miles for every 1 hour. There's the unit rate. You did something, which was going 8 miles, for every 1 of something. And that's for every 1 hour you rode. Your allowance is $10 per week. That means you earn $10, an amount of something, you earn $10 for each 1 week that you live. You eat 2 apples per day. That means you eat 2 of something for every 1 of something, for every 1 day. So when you hear that word per, there is a invisible word that comes after per. Can you figure out what that invisible word is? It's 1. That invisible word is 1. You eat 2 apples per 1 day. Your allowance is $10 per 1 week. You ride your bike 8 miles per 1 hour. It's not written there, but per and each and every mean that there's a number 1 there. That's the unit rate. All right. So you remember that I was telling you that we were going to start talking about collecting things. So I'm on page 13 in our book. So please with me Turn to page 13 so that you are following along. You can write things in your book right while I'm teaching the lesson, just like if I was with you there or if you were here with me in the classroom. You can get a start while I'm teaching. Then you also know just what to do. Also, remember, you don't have to watch the video straight through. You can pause it, you can go back, you can step away for a minute and then come back. You can rewatch, so you don't have to watch it straight through, but you do have to watch it before you're going to be able to do this. Okay? So, first of all, the first question talks about Pedro and Pilar, and they're collecting snails. Now, when I hear that, I think, who collects snails? Okay, weird, but you know what? People collect whatever they want, right? So I love collecting rocks, as you know. What do you like to collect? Okay, so let's read number 1. It says Pedro and Pilar collect snails. Each day, they add 4 snails to their collection. All right, this is where we have to stop and think. Constant rate. Each day, every single day, they collect 4 snails. How likely is that? Probably not real likely, right? I mean, first of all, I don't know where they're collecting them, maybe along the shoreline or something. But do you think every single day they collect 4 snails? Don't you think, whoops, weird, hold on, yikes. Oh my goodness, I'm having some trouble here. Something happened to my, sorry about that, my computer just did something really weird. But I'm back. I don't know if you saw that. That has showed on your screen, but my screen just did something really weird. So sorry about that. Okay, so back to Pedro and Pilar. So every day they go out and collect 4 snails. So they go out collecting. Do you think they always find 4? Maybe sometimes they find 5 or none or 10. What if they're sick? They probably don't go out there. What if they're super busy? What if they go out of town? What if their family says, well, we have to spend the day, we got errands to run, so we're going to spend the whole day running errands. Do they say, no, mom, no, dad, no, grandma, no, grandpa, aunt, uncle, I can't run the errands with you, family. I have to go out and collect my 4 snails. No, that doesn't make sense in the world. But you're just going to forget about that and pretend that it does happen. And that's what I'm doing here with my rocks. Do you think every time I go out and look for rocks, I get the same amount? I can tell you that I've got 2 different collecting times right here. This time, I found a gigantic rock. I loved it. I collected it. But how many of those could I have actually collected before I wouldn't have been able to carry them anymore? Not very many. On the other hand, the day I was walking along Lake Michigan and finding all these super smooth round ones, as you maybe have heard me say before, I love like smooth round or like ovally shaped rocks. Look at all these I collected that day. That's what real collecting is like. You're just going to have to pretend, though, that they do collect at the exact same rate, that constant rate, every single day, the same. Even if you have to pretend, because we know it's not really like that. So, Pedro and Pilar, they collect 4 snails every day. First day, how many snails do they have? 4, right? What about the second day? How many snails do they have? This is where you could be writing right in your book. Now, I'm not going to write in my book because it's hard to see, but you are writing right in your book. So we've got the table that says days. We've got the table that says snails. First day they go out, they collect 4 snails because we know every single day they collect 4 snails. Second day, they go out, they collect another 4 snails. How many did they have? Well, you'd say 8. What if some die? Nope, doesn't count. Remember, when we're talking about a constant rate, it's the same. Third day, they collect another how many snails? 4, because every day they collect 4, no matter what. So if they had 8 the day before, now they have 12. This over on the side is what we did yesterday. They add 4. They add 4. They add 4 every single day. Every day they add 4 snails. Every day. Now, what we are doing over here, though, we've got something else that we're going to do over on the other side. we might be noticing that there's also something with multiplication going on. Remember, addition, oops, my lights turned off. Hold on. Oh, there they go. Remember, addition is repeated. When we repeat it over and over and over, we call that multiplication. Multiplication is just repeated addition. So over here, we're timesing it. There's something being multiplied over here, something being multiplied over here, something being multiplied over here. We're going to figure out what it is to write in those things. Okay, we're back. So I got a different color marker. So let's talk about what we're going to write on the other side, the multiplication side. We're thinking that we could figure this part out right by adding 4, adding 4, adding 4, adding 4. Repeated addition. Let's talk about what that looks like with multiplication. We have one day multiplied by the number that we're collecting each day, 4, which is 4. What about the second day? How many days have we been collecting? We've been collecting for 2, multiplied by, what are we going to multiply by? Still 4. Don't let that trick you. We're collecting 4 every day. So multiplied by 4. Now it's 2 days times 4. And look how that corresponds to the answer of the number of snails. The third day, we're still collecting 4 every day. So it's still multiplied by 4, 3 times 4. And that shows us that now we've collected 12 snails. So keep going in that pattern. The number of days we've been collecting times every day we're collecting 4. So here it's 4 times 4. What would that answer be? Continue on while I turn our lights back on. All right, I'm back. And I've turned the page now. So now I'm going to be working on page 14 of our book. So make sure you're with me, please. Have your book available. Now, on these problems, it's going to ask us, first of all, if it's a constant rate. Is it the same thing over and over and over and over? For each one of something else, is it the same amount? Or does the amount change for each of something? For instance, if it changed, if the amount of apples I ate changed throughout the week, maybe Sunday I didn't eat any, so it was 0. Monday I ate 1. Tuesday I ate 2. Wednesday I ate 0 again. Every single day, each one day, the number of apples, it's not constant. That wouldn't be a constant rate. So what would we do if we found something that wasn't a constant rate? You know what I'm making there? A giant Ghostbusters sign. Yep, you're going to say, nope, that's not a constant rate. So that's what we're looking for in these. Is there a constant rate? And if there is, what is it? And then write it using the word per one what. Some number happens something per one what. That's what we're doing. Let's read number 4. Number 4 says, in the zoo, 7 kangaroos live in each kangaroo house. We heard the word each. Each, every, per means 1. So 7 in the zoo, 7 kangaroos live in each kangaroo house. How many kangaroos live in the first kangaroo house? 7. Told us that. How many kangaroos live in the second kangaroo house? 7. 7 lives in each house. Each of those kangaroo houses have 7. After we take 2 houses together, how many do we have? Now we have 14 because 7 live in each one. 7 and 7. So let's see. It says, is there a constant rate? Yeah, there is. We heard about it. It's 7 kangaroos live in each house. But now, so we're going to put a yes there. Is there a constant rate? Yes. Now it says blank blank per blank. We hear that per and we know something comes after that is 1. So the number that's invisible, you can't see it right here, but there's an invisible number 1 right there. Something, something per 1 something. What is the thing we're talking about that's the 1 in this case? I hope you thought about that and said, it's kangaroo houses. It says kangaroos live in each kangaroo house. After the word each comes an invisible 1. So blank blank per 1 kangaroo house. So what is the blank blank? It's 7 kangaroos living in each house. So we're going to write that 7, and I'm just going to abbreviate kangaroos for kangas, 7 kangas per house. That's the first part that it wants us to fill out. It wants us to say yes. Yes, there is a constant rate because every single house has 7 kangaroos in it. There are 7 kangaroos per invisible 1 house. So the unit and the product in every house, there's 1 house per 1, per means unit, per is 1. So per house, and then how many number of kangaroos, and it's going to tell us the total number of kangaroos. So in 1 kangaroo house, there's 7. But if we have 2 kangaroo houses, there's a total of 14 kangaroos. If we have 3 kangaroo houses, see how we're adding 7 each time? Plus 7. Another house, another 7. Now what's the answer? 21. If we have 4 kangaroo houses, another plus 7. Each house has 7 more kangaroos. What would it be? Now what about over here? Remember, this is where we do the multiplication. There's 1 of something times how many for each 1? 7. 1 times 7 is 7. What if there's 2 of it? And the unit rate is 7 per 1. We have 2 of them. Now it's still times 7. But notice how that matches up with our answer of 14. What if we have 3 houses multiplied by the 7 kangaroos that live in the 3 houses? See how that connects? Your task for today is to continue to read the situation. Ask yourself, is it happening at a constant rate? Same thing over and over, never changes. Or does it change? If it changes, take your pencil, go like that, show us that it's a Ghostbuster sign, and then say no constant rate. Now, in this case, this was 1, so don't get tricked, but say no constant rate and then tell us why. Why would it be? Because the number was changing each time. Don't get tricked. If you have questions, reach out by email or chat or come to our small groups. I will see you soon. Bye.